Should we do it? Right on. All right. So yeah, let's start with this one. Brandon, what do you think?
Pull out the 4/3.
Love it. Get rid of that constant, right? So that 4/3 comes through the integrand. Keep in mind, variables never can come through there, right? Just constant multiples. Good. Then what?
Change it into x to the negative half.
I love it. Dx. No questions, right? Bring it up to the top. Go ahead.
Then you just antiderive it, so it's 2 to the 2x half. I don't know if it's oh yeah.
Did you say 2x half?
Yeah.
I think that's right. Yeah. Speak at it. Yeah, good. I think that's going to be what? 8/3? Good. So this is going to be 8/3 x to the 1/2 plus c. That's right. What do you got? Come on, let's see. Good. What do the rest of you guys do? Was it? You got it. You got it. Okay. You're good? You're good? You're good? Okay. Yep. I like it. I like it. All right, let's talk about this one. Can we do these separately, Kyle?
I don't think so. I didn't know how to do it really.
Yeah, you got it. Colin, can you do these separately?
Yes.
You sound uncertain. Andrew wasn't even here. Yeah, let's see here. Caitlin, can you do these separately? The tangent square doesn't work, but theoretically, if they both work, I could do these separately, right? It's just like deriving. Anti-deriving works the same way. You could do them separately as long as you are adding or subtracting. So we can just take this and really do this. You guys with me? Remember, the integrand and the dx always occur in pairs. You're just signaling that each one individually is a derivative with respect to x. Skylar, secant squared anti-derives to what? Tangent of x. This part's done. Plus c, right? And we can just add the two c's together at the end. 2, of course, just get c, as we talked about yesterday, right? Cool. What am I going to do here, Olivia? Good. What is tangent squared equal to?
Secant squared x minus 1.
Secant squared x minus 1 dx. Good. I'm not going to split that any farther, right? I could split them if I wanted to. Let's take these one at a time. What's this then, Zach? Good. So I really have 2 tan x, right? And then this goes backwards, Taylor, to what? Because I do need to anti-derive that, don't I?
Yeah.
Taylor. Yes, Taylor.
Wait, you and the whole thing, doesn't it just go back to tan?
Well, hang on here. That goes to tan. This has got to go somewhere.
Oh, minus n.
Oh, I love it. Minus x. Right? Yep. That's going to be 2 tan x. Hello. Minus x plus c. 2 tan. Is that possible? Yes, it is. The sun is a killer. 2 tan x minus x plus c. All right, here we go. Hey, how about this one? This has a quotient. I don't like this, Ben L. What do we do there? Good. Hang on here. Let me just write this down. So I got 4x squared plus x minus 1. All that to the times, rather, x to the negative 1. What the? Third dx. Don't like it. Product.
I multiply it out to 4x to the 5/3 plus x to the 2/3 minus x to the 1 -1/3.
Okay, let me pause right here for a second. I'm going to get rid of this because it's getting crowded up here. Does everyone understand what's going on? Same base, add the exponents, correct? I think he's good.
Yep.
6/3 minus 1/3 is 5/3. So that's 2/3 negative 1/3. I think we are good to go. Excellent. Let's take this one at a time. Jonathan, what's this go to?
3 halves x to
3 halves x to the
the 8/3.
8/3. So it's x to the 8/3. And that's what? 3/8. That's 3. Did you say 3 halves? I think that's right, isn't it? You get the 4 and the 8 to cancel. I like it. I like it. Sarah, what's this go to?
3/5 x to the 5/3.
3/5 x to the 5/3. I like it. Connor, what's this going to?
3. Oh yeah, 3 halves.
I like it. This is going to be, and is it positive or negative?
Negative.
Are you positive?
Yeah.
I think it's negative. Yes. So this is going to be negative. What did we say this was? 2/3? No, 3 halves. Excuse me. I got a copy dot flop. Minus 3 halves x to the 2/3 plus c. A lot of reps at fractions on this stuff, right? Yep. As if you didn't have enough practice already, you're getting more. All right. How we doing, people? We all hanging in? Love it, love it, love it. Fascinating. Evan, can you handle it? You got this. What's this go to?
That goes to cotangent.
Cotangent, good. So that's 4 cotangent?
Yeah.
Yeah, don't be so positive, Evan.
Oh yeah.
I believe it is negative, right? Because cotangent has a negative derivative, right? If I want it to be positive, it's got to be a negative negative. Kaylin, what do you do here? I like it. So it's going to be x, negative x to the negative 2. Good. And what's that give you then? Does it? I think that's right, right? So that's x to the negative 1 over negative 1. That's a negative negative. That's plus 1 over x plus c. Everyone understand that? All right, I didn't write it out, but are we all good? Nice, Kaylin. That's it. That is why. Perfect. We feeling okay with this stuff? Yeah, trig gets a little tricky, right? But not too bad. Just stay, please, please, please stay on top of the anti-driving. I think I mentioned that. It's kind of a bear, and it gets harder. But we'll stay on top of it, one day at a time. All right. So we are going to go on to 4.3 today. I'm not going to put it on the quiz. I did tell you guys that already, right? It was my other class I didn't tell. All right. Well, also don't forget, if anyone was gone, don't forget about the mini project, right? Mini project. It's on my website. Just check it out. Does that do Tuesday? Do Tuesday, yeah. Do Tuesday. Okay. Guys, it should take, you could probably do the whole thing in an hour, something like that, hour and a half. But I'm going to count it as a quiz score. So I'll make it worth your while, right? So if you counted like time studying, maybe time doing homework for a quiz, hopefully it'll be about commensurate time, something like that. All right. Cool. And just email me or let me know. Stop by sometime if you have any questions as to how. All right. So got a couple of questions on the homework. And of course, they're all different. So I'm going to make an executive decision and pull some out that are representative of the things we should do. 78 and 79 out of 4.1 rather, I think. Yes, 78 and 79. I know some of you guys were in here this morning. We were talking about this. I think I'll do, let's see here, for the position fund. I did 79 this morning, so maybe I'll do 78. Cool, so you've got x of t is equal to, what is that, t minus 1, and this is t minus 3 squared. And I'm going, my t values are going from 0 up to 5. All right, guys, check this out. Everyone stick with me here. If you have a particle zipping around on the x-axis, right, it's just like a projectile motion problem, but sideways, right? So the position function will give you its position along the x-axis. It is sign sensitive, of course, right? Let's say you have some time t that actually gives you a negative x. Like, so let's say after 5 seconds, you're at -4. All that means is that particle's at -4 along the x-axis, right? A velocity is also sign sensitive, right? So if you have a positive velocity at some sort of time, it is moving to the right. It's moving in the positive x direction, right? If it's 0, it is paused. Do I know for a fact it's going to zip back the other way if at a moment it is paused? Not necessarily. Could the particle be going like this, pause, and then continue on? Okay, good. So if this is position, Connor, how do I get to velocity? Love it. So V of t. Let's just go ahead and drive that really quick. Go ahead, Connor.
T squared.
Are you foiling this out?
Yeah.
How about this? Let's just drive it the way it is. Why not?
Oh, yeah.
I know, deriving, right?
Yeah. 1
Yep.
times t minus 3 cubed.
Is it cubed? I think it is squared. Yeah. Continue.
And then 1, 2. I'm so
It's all right. Take your time, man. Take your time. Are you doing product roll, Connor? It appears that you are. Yeah, I like it.
Yeah.
So how about this? Remember, you drive this, don't drive that. Then I'm going to not drive this.
Yeah. T minus 1 and then 2 t minus 3.
Now you're cooking.
So 1.
Now you're cooking. Good. How we doing, people? We good? That's definitely velocity, right? Then you get acceleration. Just drive it again, right? By the way, you could clean it up. It gets a little messy here, right? Because then you get products on top of products on top of products. I would just drive it again. I'm not gonna do it. You guys with me? Okay. Good? All right, cool.
Can you do part B?
Yeah, part B. So part B says, oh yeah, thanks. So it says, well, actually there isn't a part B for 78.
It's like, it's the same as for.
Oh, I'm so sorry. You're right. You're right. Now it says velocity and acceleration. And then for part B, it says, find the open intervals on when the particle is moving to the right. All right, now hang on. How are we going to do this? Is it really just intervals of increase, decrease, the position function? Ain't it? Look, it's the same thing, right? Intervals of increase, decrease. So what I want to do is I got to find, how do I find where the potential intervals of increase or decrease, where they potentially change, Cal?
You plug in 0.
Beautiful. You find critical numbers, aren't you? It's the same process, except now you just got sideways movements, essentially. Good. So let's do that. Let's. How about this? Check this out. I'm going to take out a t minus 3. Why not, right? That way I don't have to FOIL it all out. And when I do that, I'm going to get what? T minus 3 plus 2 times t minus 1. Kind of weird factoring there. Can you guys all see that? They do this a lot in the solutions manual. This is a plus, by the way, not a T. Everyone see what I'm doing? Does anyone not see what I'm doing? All right, let's continue to simplify. So this is V of T. This is actually going to be what? T minus 3. Yeah, go ahead, man. The second one is going to be T minus 3 plus 2T minus 2. I think that's 3T minus 5. Is that right? You guys okay today? Pretty fresh in here? You all right? All right. I don't have a candle on, so it can't be like CO poisoning. All right. Okay. It's just period 5 on a Wednesday. All right, here we go. Let's get some critical numbers, Taylor. Go.
3,
Yep, and
5/3.
I love it. 5/3. Oh, wait a minute. How do I determine when it's moving to the right, Ben M?
Plug it in.
Plug what in?
Around.
Oh, I like it. Let's put it on a number line. I got 3. I got 5/3. This stops at 5, right? Let's pick.
Wait, yeah.
That's absolutely wrong. That is ridiculous. That's 5/3, and that's 3. Good morning.
Yeah, I know.
See, I'm telling you. I think it might be CO poisoning. I don't really know. All right, let's pick one over here. Okay, now you got to be careful. It's got to be less than 5/3. This is super challenging. Kyle.
0. Or 1.
Yeah, okay, let's just be safe. I think it's written so it includes the endpoints, but let's just plug in 1. All right, what about this?
2.
I like it. What about this? Good choice. Colin, you love 4. All right, okay, good. Let's plug 1, 2, and 4. By the way, Colin, where are we plugging 4 into? I mean, excuse me, and 2 and 1. Where are we plugging these into?
No.
Listen, I could if I just wanted to figure out where it was at those times.
Yeah. It's slow.
I think the slope machine, right? The slope machine is going to tell me whether it's moving to the left or moving to the right. Let's plug 1 in here. Negative. Wait, right? Yes, I have to be careful today. So this is negative, and this is also going to be negative. I think that's positive. This is moving to the right. Well said, Evan. Let's plug in 2. Negative, positive. This is moving left. 4. Yeah. The open intervals, when it's moving to the right, is going to go from 0 to 5/3. Right? And then again from 3 to 5.
So if the
Yeah,
elements
like
are included in this one, would it be a closed
Yeah.
bracket on this side?
But here's the deal, guys. Do you agree this particle is paused at 5/3 and 3?
Yeah.
But the endpoints it should be bracket.
Okay, just make sure.
Unless the endpoints just happen to be critical. You good?
Yeah.
Okay, awesome. Is that okay, Connor? All right. You good, cat? Perfect. Did I tell you my spooky Halloween joke?
No.
You know, I decided kind of not to because I told it earlier in the day. It wasn't well received. I don't know. I'm a little frightened
We
to
were all
tell it.
waiting for it.
Yeah, you were.
That's a good
I'm a little frightened to tell it. Hey, thank you.
okay.
Come on. Yes, exactly. Fine. All right, I'm going to tell it.
Alright.
What? Oh, I don't know. I'm recording. I don't know if I should tell this. All right, let me cover the microphone. Okay. Are you ready, Kyle? No one's too frightened, are they? There's a psychopath. I told you it's scary. It's Halloween. Oh, wait. Here comes Zach. Nothing. Zach, I have a joke for you.
Okay.
It's the Halloween joke I was going to tell the other day. I almost didn't tell it because I told it early in the day. I don't know. I think it's super funny, but no one thinks it's that funny so far. There's a psychopath. I did tell you it was scary, right? Okay. Psychopath, and he's walking this kid out in the woods. It's literally a dark and stormy night. Kid goes, "Oh, I'm scared." He's like, "You're scared? I got to walk out of here by myself." Thank you. Thank you. See, I think it's funny. And it was just like,
it's good.
it was just crickets or like distraught looks like, what are you doing? Don't tell that joke.
What?
Yeah, that's just a joke, and it's Halloween. All right. Was I done with this problem, by the way? Okay, good. I'm erasing it already. Now, here's the question. The question was setting up the area problem as well. So let's work through one, but I'm going to change it up if you guys don't mind. Sound good? We'll change it up. I'm going to work another one that's not the same one that we did this morning. It'll be similar, right? We'll see if we can set it up together. We'll crank through it. Then we're going to do 4-3 today. I promise you, 4-3, even though it's not, none of the quiz is not. I think it makes sense. It's nothing that's going to be super challenging today. Okay. So, here we go. So, I think I'm just going to make it up. I'll make it similar to the ones that we've done, right? All right. So here we go. Yeah, f of x. Let's do 1 minus 2x squared. Close enough to like the homework, right? I know it's not exactly. And I'm going to go now from 1 to 4. Yeah.
Wasn't this the one we didn't advise?
Is this one of the homework problems?
No, it's the one we didn't advise. This morning. I don't know if that matters.
Is this exactly the same one? Are you kidding?
Yeah, well, yours was 1 to 3 and 5.
Oh.
Oh, yeah. The
Yeah, it was
Mm.
actually after that.
Okay. So let's do 2x squared minus 1. Totally different, Ben. Totally different from 1 to 4.
Okay.
Totally different. Yep, I know. Bless you, Skylar. All right, people. Remember, all you're doing is building the area formula into the summation process. Jonathan, remember how this works. I'm going to sum from I equals 1 to n. Go, Jonathan. What's the width of every single one of these rectangles? You are so close. You are getting colder. Three over n. Every single time. 3 over n. Right? It's the difference between those two. You are going from 1 to 4. That is a distance of 3. If it was 7 subintervals, wouldn't it be 3 sevens?
Yeah.
45 subintervals, each one would be 3 47s. I think I said 47. Okay, good. Forgetting as I'm speaking. 1 trillion subintervals. Each one will be 3 1/trillionths wide. This is going to be 3 nths wide, and n is going to be big. All right, Zach, remember what goes in here now. It is f of what?
It's left. This slope is 1.
Left endpoint, good, so 1.
Okay. Plus whatever that is, so 3 over n.
3 over ni. I don't even know. Again, I hate to say this as a teacher. I don't even know it's that important to even understand what you're doing here. I would like you to understand it. This is the width. You have something like this, right? If you're going from 1 over here to 4, the first rectangle that you're coming up with is going to be f of 1 plus 3 1/billions. That's what you'll get when I is 1. The next one will be at 1 and 6 1/billions. That's what you get when I is 2. And that's the way summation notation works. It goes from 1 to 2 to 3 to 4 to 5. Every single time you'll bump over 3 1/trillionths. Sound good? All right. Next step, Skyline.
Plug that in for X.
Love it. This is f of this. The way I do that is I take this, plug it into the x in f. This is the sum from I equals 1 to n. This is 3 over n. This is going to be 2 times 1 plus 3 over ni minus 1. That should be squared.
Yes.
Good morning, right? 2x squared minus 1. The x is now 1 plus 3 over ni. You good, Jonathan? Okay. Excellent, excellent, excellent. Can't have products, can't have quotients raised to a power. Colin, what shall we do? Multiply it all out. Let's FOIL it all out, get them separated into pluses and minuses. Here we go. Sum from I is 1 to n, 3 over n. This is going to be 2. 1 plus 6i over n plus 9i squared over n squared minus 1. Not 1. Never gets old. Never, to me. Everyone understand what we're doing? All right. We clean up the innards a little bit, right? Isn't it true if I distribute the 2? Sorry, Zach. Let's see if I hear. Check this out. Is that a little better? Okay. So I'm going to distribute the 2 while I'm at it, right? So isn't this going to be 2? This will be a 12. This will be an 18. And we got the minus 1 at the end. Good, Caitlin? Cool. Then I'm going to do 2, take away 1, and clean that up as well. That'll just give me 1, won't it? Cal, you hanging in? Maybe? Or yes?
Yes.
Cool. 2, take away 1. Here's 1 here. Are you good, Skylar? Okay. Then M? Totally good? Let's distribute. Pull stuff through. All right, here we go. The first one, this is the sum from I equals 1 to n. Isn't that going to be 3 over n? Next one is going to be the sum from I equals 1 to n. That's going to be 36i over n squared. Last one is plus the sum from I equals 1 to n. That's going to be 54 I squared over n cubed. Good? Does everyone see what I'm doing? Ben Al.
Yeah.
I thought you were raising your hand. Sorry. It's like an auction. Yeah, gotta be careful. All right. Hey, Victoria, you were asking me about this.
Yeah.
So the next step, let me know if I'm losing, okay?
Okay.
Well, all I want to do is just pull through the stuff, except for that for which I have a formula. Right? And there are 4 formulas, Andrew, that are in your notes, okay? Okay, so this one I'm gonna pull everything through except for the constant. Technically, isn't 3 and a constant. I'm gonna do it right it this way. I can clearly see the constant, right? Like the numeric constant. Look,
When we're like writing on a test, do you want us to keep writing the
No.
sigma thing? Okay.
you can just do the summation.
Yeah.
You don't need the topic. I know you get writer's cramp after a while, right? This is then gonna be plus, what the? Needs to be higher, plus. That's 36 over n squared, sum of I squared. That's not I squared, that's just I. Thank you. It's all about I. Plus 54 n cubed, sum of I squared. This does get quicker, right? After you go through it a few times. Taylor, you okay?
Yeah,
Are you sure?
yeah, I like did it, but then I got that. Yeah, no, yeah,
Okay, but you're okay with what I'm doing.
yeah.
All you got to do now, put in the formulas. Here we go. 1 over n, 3n. 36 over n squared, that's n. N plus 1, all over 2. 54, n cubed, n. N plus 1, 2n plus 1, all over 6. All All right, Sarah, what do we do now?
Yeah, now we make the limit as x goes to infinity.
Love it. I want a lot of subdivisions,
Yeah,
like a lot. This thing right here, Sarah, goes where?
3.
To 3. You're only using the most dominant terms. This right here, you got to be careful. I think that's 18.
Yep.
This thing right here is 108 divided by 6.
Also 18.
That's 18. 36, 39. Don't forget the 2 here, Zach. Maybe that's what's throwing you off. Or maybe not, right? Isn't it true? This is going to be 108 n cubed over 6n cubed. Nothing else matters. They are all inconsequential by comparison. Pretty cool. Yeah. I mean, seriously, it's still fascinating to me. It's pretty cool that it could technically be that easy. And again, I know when you walk in, it's like, that doesn't look that easy. It's actually just a bunch of arithmetic, right? Just multiplication and stuff like that. Okay. Taylor is frowning.
No, I get confused at like where you simplify the square.
Got it.
I can never get it right. That's like a lot.
I'm with you. So let me just work through this really quickly. If I FOIL that out, you guys remember the old FOIL box?
I do that sometimes.
I know this uses a lot of paper, but you can never go wrong, right? Especially if you're cubing things and stuff like that. You just multiply the rows and columns. 1 times 1, wait, carry the 1. This is going to be 1 times 3i over n. Good? This is also going to be 3i over n. And isn't this just everything times itself? 9i squared over n squared. I should think this helps, especially difficult stuff like this. So this is going to be 1. These are like terms. I over n. Got 3 of them here, 3 more here. 6 I over n's. 9 I squareds over n squareds.
Then does like the 12 I over n like how you distribute it to?
Yeah.
Okay.
That's kind of the problem, because I was erasing and distributing and doing stuff like that. Sorry about that. I should have rewritten it. I was just trying to save time, and it clearly saved no time at all. It caused more time. Victoria.
When you put the
Yeah.
constant on the other side, you just put that constant in the end.
Wait, one more time.
Like the 3 goes to the end.
Yes.
Any constant just goes to the end.
Any constant is the constant times the upper index. All. How we do, people? You're not raising your hand. Okay. All right, sweet. Did I get everything from the homework? We go to 2:30, right? All right. I think what we're going to do now is we are going to take a brain break. Good?
Yes.
That's long. You don't have quiz test days. You just to get no breaks, right? So if you guys want to stand up, we'll do like 3-4 minute break. You can go get a drink of water. Please just keep it down in the hallway, okay? You get a drink of water. You what? Yeah, you can go to the bathroom too. Yeah. Even if you're just staying in the room, just stand up and chat and just chill. Right? We'll start in like 4 minutes. Are you doing okay?
Yeah.
Okay. Sorry about this, Taylor. I should have.
That's
Okay.
Yeah.
And if you're still not getting this, just let me know and I'll take a look at you.
When you're setting it up, just, yeah, that's easier. It's always 1 plus the interval times I.
And the number over n is always the distance between the over the interval. Yes.
Okay.
Always.
Thank you.
Yeah, you're welcome.
Wait, so like,
Yeah. It's full day, so we gotta get a full script.
Oh, okay.
Let's push over like what was the one you said about it?
On the floor.
The pink one?
Yes.
I want a pink calculator.
Oh,
Look up.
Hey, Andrew. I might might have a video. Did you look and see my video?
Dude.
It's so much
So-
It's the fastest way to do this. If you just anti-derive it, plug in the farmost endpoint into that, and then the leftmost endpoint into that, and you subtract them, and it gives you.
How did you come up with that?
I didn't come up with that. I found it because I kept messing with the homework class.
Okay, John, does it always work or?
No days off,
Lightning
JV.
fast internet.
No days off.
Just a blink of an eye.
Like you sleep, it's like, yeah, I know, but like, how did you find that?
He's probably in teacher.
Connor, you're too smart.
Push up.
Here's where you gotta go. Don't go to
We're just sitting around.
You, like, you anti-derive it.
John found the fastest
He's a
way to do
mathematical genius.
I haven't had them yet, so I love them, but like, apparently it's terrible.
I loved him until.
I feel like I teach us that all.
Yeah.
Probably we're gonna learn
Best
today.
Jonathan, don't ever tell anyone that.
I
Okay.
don't know. I like people.
Keep your mouth shut, John.
Keep your mouth shut, Jonathan.
Yeah, whatever. Yeah.
Oh.
Okay.
I remember us talking to one of my dad's friends. He did that on a calculus test. He's like, everyone took an hour and a half to take the test. I finished in 20 minutes.
We are doubling. We have to get to
That's
10. We're like 4.5.
But
But I think it's,
And that's
you don't
double.
really appreciate it.
Exactly.
Like you're doing it. And so
Because there's
you can
different
conception
amounts
of what
of
you're doing.
You understand why that.
Exactly.
There were a lot of experiments.
Yeah, I know, but like, this is from a numerical standpoint.
Jason was practicing chain rule and advice, and I gave him a like.
You feel like you have a lot of time now?
Oh, a squat
Yes,
one is
it's a lot better.
Yeah, that's good.
Yeah.
That's
You
good.
did it.
Congrats, by the way. That was an awesome season. Super good. Super excited.
I have made my retainer today with Adonis. After, no joke, 9 years, 7.5 years. Finally getting my retainer.
Is that the greatest feeling ever?
It's awesome.
All right, people, here we go. Let's do it. Yes, sir.
I gave Jason this problem this morning so he could do a chain roll.
And he did it.
Nice. Who'd you give this to?
Jason.
Nice.
Yeah, it was fun.
That's
It's fun doing on the giving end.
That's what I'm talking about. All right, people.
Yeah, it has everything.
All right, here we go. Section 4.3, all right? It's called area, continued basically, right? But before we get there, I have to show you one more thing from 4.2 that I'm going to put on the quiz, I'm telling you. This next thing I'm going to put on the quiz, all right? So it is 4.2 continued before we dive in, and it is called the Riemann. It's called a Riemann sum. It's a different way of looking at area estimation, okay? A Riemann sum. Or EI, yes. He's a German mathematician, was a German mathematician. And this technique basically, he came up with, right? It's nothing groundbreaking, but here's what it looks like. Let's say you've got a table of values, right? And so it's like 1, 3, 5, 7. Let's do 7, 2, 11, 14, 12, 0. And those are just ordered pairs, giving you points on some curve, right? Some functional curve. 3, 7, this is not to scale. 7, 2, 11, 14, 12, 0. So whatever this curve looks like.
That looks so good.
That's kind of cool. Yeah, it looks like mountains. Colorado license plate. Now, here's the deal. There's two ways to calculate a Riemann sum. There's a left-hand sum and a right-hand sum, okay? And if you think about it, it's very much like what we were doing in class, right? Let's say I went from 0 over here to 2. with two subintervals. If I did a right-hand sum, I'm using the right-hand side of every single interval to form my rectangles. This would be a right-hand sum. You guys with me? If I use a left-hand sum, it would look a little different, right? In fact, I'll draw it out here with red. If I do a left-hand sum, now what I'm doing is I'm using the left-hand side of every single one of these intervals to determine the height of the rectangles. Yeah, so I'd get something like this. So the red rectangles represent a left-hand sum. The blue rectangles represent a right-hand sum. Now theoretically, like you could add the two together and divide, like take the average of the two, right? But you're still gonna have yourself more area than you think, because clearly the blue is far higher. Red. I'm only gonna ask you to calculate a left-hand or a right-hand sum. I'll just give you a few of these practice tonight. Keys on my website, on my calendar. Okay? So I'm gonna show you how to do this without drawing this. It's essentially the same thing, okay? So check this out. All you're doing is coming up with areas of these rectangles, one interval at a time. Now, the thing about the Riemann sum is also that these are not necessarily equal, right? First one could be really wide, next one could be very narrow. It just depends on the dots I give you on the function. So let's start off with a left-hand sum, okay? A left-hand Riemann sum. And here's how this is going to work. You just got to get in your brain that you are taking width times height. All right? So the width of the first rectangle is going to be how wide, Kyle? Isn't it going to be 4 wide? Right? So I got 4 wide. Now, here's the deal. These are 2 y values. I'm going to use the left-hand side to calculate the height. So it is 3 tall. These are my 2 heights. These are my 2 y values. I'm using the left-hand side. Let's keep going. I'm going to add this then to the area of the next rectangle. I just slide right over. This is 2 wide, not to be judgmental. Remember, the axes are the width. 2 wide times the left-hand height, which is 7. Move over next interval. This is 4 wide times the left-hand height, which is 2 in this case. You guys understand what I'm doing? Now I move over again. This is 1 wide times the height of the left-hand interval. Multiply those together, add them up, that's it. Nothing groundbreaking, very easy. Also, not even a great estimate, I would add. Right? Okay. Let's do a right-hand sum just to make sure that we're good. Right-hand sum, similarly easy. 1 interval at a time. First one is 4 wide times 7 tall. It's literally the right-hand number as you go, right? So this is 4 times 7 plus 2 times 2. Plus the next one is going to be 2 times 14. Next one. Oh, sorry, that's not 2. That's 4, right? Times 14. Next one will be 1 times, do it right here, 0. That's it. Pretty easy. Questions? All right. I'll put one of those on the quiz. It'd be like a bonus. Cool. All right. Enough about that. That ties up 4-2. Let's do 4-3 then. All 4-3 is getting you used to new notation. Okay? That's not all there is, but it's most. Getting you used to new notation. All right? All right, here we go. So let's say that I've got this picture here. And it's like this. Let's call this -4, -2, and we'll call that 5. Not to scale, right? And what I'm looking for is the area between the curve and the x-axis, right? We'll call this f of x. So check this out. if I wanted to go from -4 to 2, setting it up like I did before, Victoria, are you ready? How would I write this in summation notation? Just going from here to here. So this, there to there.
It would be 6
Yep.
n or over n.
I like it. I like it.
And then f of -4 times 6 over ni.
You bet. Yep, bippy. Are we good? All right, Jonathan, I'm going to take that and add it then to the area from 2 to 5. Go for it. What is it? Yep, continue. You mean 2 plus? 3 over n. Ah, beautiful, beautiful, beautiful. How we doing? Good? All right, now stick with me. I just want to make sure everyone's clear on what's going on here. Do you guys agree? You take 6 and divide it by a trillion or a billion. Those are positive numbers, albeit tiny. Positive. Now, if I have y values and I'm going from -4 to 2, do you guys agree? According to this picture, I have positive y values. I'm plugging in this x value here. I get positive, whatever it is, right? This is positive times a positive. Doesn't this give me a positive area figure? You probably see what's going to happen here, right? If I do the same thing here, do you guys agree? 3 divided by a trillion, also positive. The difference being now, when I plug in these x values and I plug them into f of x, they are negative. So this is a negative, which gives me a negative area value. So it is possible for you to, if I said, hey, listen, what's the area between f of x and the x-axis from 2 to 5? You can give me a negative number. That's what I'm looking for in this chapter. If it's below the x-axis, I want the negative number. You guys all with me? That's what I'm looking for arithmetic. Do not absolute value it. Give me that negative number. Good? Now, listen, this isn't to scale. Is it possible that I could add this area to this area and get 0? Yeah, they could be offsetting, right? You could have positive on top, negative on bottom, offsetting. I want 0 for that answer, right? Don't absolute value them and add them together. No, give me the number. If they cancel, they cancel. Good? Also, if let's say this was slightly bigger than this, you could have a really small negative number 2 if I went all the way from -4 to 5. Everyone with me here? Okay, I think I'm beating that to death. I think we're good there. All right, now the new notation. How about this? Let's just focus on this part right here, right? New notation now will not be summation. We're going to just transfer over to an easier way to do this, basically, right? With some new notation. This operates a lot like this. I've said that several times, right? Anti-deriving is very similar to summation. In fact, I want you to start thinking about them as being really the same things. That S kind of looks like an S for sum, for summation, right? What I'm going to do then is I'm going to put in these expressions. I need an expression for the width and for the height, all right? The height is just going to be the function. Would you guys agree? Whatever that is. Let's call this f of x. And then check this out. This part right here, you guys agree this is the width of every single one of those rectangles? Isn't that just a tiny, tiny little bit of movement along the x-axis? What do we call that in differential school or calculus school? What is a tiny little increment of movement along the x? Cal? Delta x. In fact, delta x is even the bigger form. Dx is the tiny one. So let's use dx, basically the same thing, right? F of x dx. Everybody stick with me. I know that looks just like an antiderivative. So what you're going to do now, to note that this is area, you're going to put some boundaries on it, all right? And I'm going to put the boundaries, I'm going to write them right next to this little S thing. Put the lower boundary on the bottom. I put the upper boundary on the top. This means area. The minute you have numbers on the antiderivative or the integrand, it means area. It is called a definite integral. A definite integral means area. How we doing, people? We okay? So look, if I had, can you read it okay, Skylar? Okay. Now let me back up here a little bit. As opposed to what I had on the board before. This is an indefinite integral. And it means an antiderivative. I should say it's like a family of functions. It's really like antiderivatives. If I think about the plus c, there's an infinite number of antiderivatives, right? Shifted up or down. No numbers, it's just an antiderivative. Numbers, it's area. That's the important part here. How are we doing, people? We okay? All right. Any questions so far? Are we all good? Now, guys, yeah, go ahead, Scott.
Where did you get the 5 and the 2 from?
Because it was, you kind of see it here. It was, I just did the bottom part.
Oh, so it's just like the.
It was the example I had drawn on the
Okay.
board. Yeah, yeah. How about this? Let's say I did something like this. We could do y is equal to 3x squared plus 1. And I'm going from like 1 to 6. I'm still going to do these area problems just like I did before, right? So I'm going to put this into summation notation. Skylar, this is going to be I equals 1 to n of what?
Of 5 over n
You got it?
times f of 1 plus 5 over n.
You betcha, baby. So they're going to do exactly like you did before. I'll take 1 plus 5 over ni. I'll plug it into the x in 3x squared plus 1. I'm not going to go through all that. It takes too long, right? But I'm going to give you a ton of these to do tonight. That's basically how you would find it. Yes, sir.
So it's literally just the same thing, but it's an integrand with the numbers instead of a.
Yeah.
equation.
That's just getting you used to the new notation. Now, the new notation, if I was to write this, would be the antiderivative from 1 to 6. Those are your bounds. And what would this be here? What's your f of x? It's the curve that I'm finding the area beneath 3x squared plus 1 dx. In order to find the numeric value, you're still going to go through what you did before. But if they just ask you to write it in the new notation, this is what this means. This means this. Same thing, is it not? 5 over a trillion is dx, tiny little movement along the x-axis. Here's my height of every single one of them, which is what you would get when you plug this into here anyway, wouldn't you? It's exactly the same thing. You're just spending this section getting you used to seeing this new notation.
Okay, so we're not actually doing it.
Nothing. No. Victoria.
When we solve it, are you gonna want us to take it from the integral notation?
No, I'm going to take it from here.
Okay.
Now, if I asked you just to find, tell me what this is, you're going to put it into this form and do it like you were doing it before. You guys all with me? Okay, cool. Good, 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 good. Good, good, good. Cal?
Like instead of it telling you to find the area under the thing, just give you that.
That's exactly right. And that's kind of what Sarah's saying, right? They're trying to get you used to, Cal, seeing this as area. That this means what's going on in this picture here, going from 1 over here to 6. That's exactly right. How are we doing, Caitlin? You okay? Love it, love it. All right, a couple of things about this that are just kind of subtleties that you need to know. If I had this, so I've got f of y is equal to y squared. Hang in there, Kyle. You with me, buddy? All right, and I'm going from 0 to 4. Would you guys agree to find that area? I'm summing together millions of those rectangles right there. Yes? Isn't this distance from here to here x? And is it that dimension right there now dy instead of dx. You don't like that, Cal? Tiny little movement along the y, that's x. As opposed to tiny little movement along the x, and that's y. All right, are you guys all hanging in? Zach, are you good?
Yeah.
You can get a drink of water if you want to. I will not be offended. Trust me. We good? So if I wrote this then, isn't it true? I would go from 0 to 4, low y to high y. Here's an x value times dy. Isn't this x equals y squared? So if it's in all in terms of y, low y to high y. If it's in terms of x, low x to high x, dx. Yes, sir.
It always goes like low on the bottom.
Always goes low to high. Almost always. Check this out. If I had this, just write this down. I'll explain this later. Take my word for it. If you have the area from, say, A to B, A is lower, B is higher, of f of x dx, and I take those bounds and I switch them. I get the same number, but it has an opposite sign. So if I integrate this from 1 to 6, using this right here, and I got like 7 for area. If I write this and flip this, the area would turn out numerically to be -7. This doesn't need to make any sense to you so far. I promise I will explain this later. Cal,
What is-
I promise you I will explain it soon. Go ahead.
No, I
I would like to tell, I can't tell you yet. Okay. Now, you guys will probably there is a shortcut to this, right? There's a shortcut. This has to do with the shortcut. Some of you already started talking about the shortcut. On the quiz, you're not going to be using the shortcut. I'm going to require you to do the new. So even if you know it, I want you to do the old school way, right? On this homework, I'd like you to do the old school way as well. I'll also be testing over it as well. So it's good practice. I promise I won't give you a ton. Go ahead, Olivia.
If you wanted us to find of the Y one,
To find the what?
the like area, would we do it the same? We would still set it up
You bet.
the same
Yeah.
way? Okay, we would change anything.
Don't change anything. Don't change anything. All right, let's talk conceptually. All right, a little bit more conceptually. Let's say that I tell you this. Let's do this. Okay. How about this? If I go from 0 to 3 of f of x dx, I tell you that is 4. And I go from 3 to 6 of f of x dx, and I get -1. Let me ask you this. This is area, isn't it? Underneath f of x from 0 to 3. This is area under the same curve from 3 to 6. All right. Does this need to be underneath the curve the entire way from 3 to 6? No. It just has to have one more unit underneath than it does above. You guys with me? Okay, cool. If I said find this, let's go from 0 to 3 of 4 f of x dx. Taylor, any ideas what you think that might be?
Wait. Oh. Then-
It's what? Close. I think it's 16. Isn't it 16? Here's why. Check this out. If you go from 0 to 3 of f of x dx, isn't this part right here 4, right? And that constant just goes through, just like we've always been doing it when we anti-derive, we pull constant multiples through. It's 4 times the value of the area 0 to 3. It's 16.
This is the same.
But yeah. So these are sorry, Taylor. I'm sorry. I didn't mean to. I was not trying to trick you. I just wasn't asking you very clearly. If these two are given, what is this? Based on this two, right? Here we go. Ready? What if I said, what's this, Colin? Kyle. Creaky door. Halloween. I think it's 3. And, yep, look, got 4 above, you got 1 below, add them together, it's 3. Yeah, you okay?
Yeah, was the thing you showed us earlier with like the BA equals the negative
Yeah,
AB?
yep.
B in that instance is the smaller number.
B was the larger number.
So
So it always goes lower, incorrect order, right?
lower on the bottom.
Lower bottom, upper on top. It's kind of nice because lower is actually lower. Upper is actually upper. Yeah. Go ahead, Tina.
So on like the 4 one, it's 16 to do 4 times 4.
You bet.
And then on the other one, it's 3 to do 4 minus 1.
Basically, you're doing this. Check this out. You go from 0 all the way up to 6. It might look something like that, right? Here's 0, here's 6. At 3, this is like, let's say that this right here is 3. This area right here is 4. This area right here sums to -1. So if I take this and offset it with some of the negatives, I end up getting 3. Sound good? You guys got it? Okay. What about this? Caitlin, what do you think about that? Good thing we took a break.
If it's just one plate.
Mm-hmm. You were to guess. Wildly.
0.
Yes.
Okay.
It's like my aunt. She's super skinny. She's so skinny. Just to run around in the shower and get wet. Thank you, Sarah. Thank you. It was better than the kid in the woods. Come on, people. All right, look. This has no width. It's like a stick. There's no area. What's this? Cal, I think this might be what you're thinking. What's that? Not a 1, Colin. Good. I switched the upper and lower bounds.
I guess, yeah, we don't.
I can't tell you. Oh, you really want to know why? No, I will not tell you yet, but I will tell you soon. All right. Now check this out. Here's a brain bender. Connor, you're okay so far, right? This actually is not too bad, right? Check this out. What do you think this is? Ben L is calculating. He's calculating. He's calculating. I'll give you a second. What are you thinking?
Or this 2dx.
It does look like 6, does it not?
Yeah, that's probably right.
I don't think so. Would it help? Check this out. Would it help if I did this? You guys agree that this is 4? Is it 4, right? Yep. What's this?
0.
No.
2
Olivia?
dx.
No. This has to be a number, doesn't it? Isn't this area? Connor? 6. Not O.
Wait.
I will. It is too tall not to be judgmental and 3 wide. not oh, 3. It's 2 tall, 3 wide. I'm going from 0 to 3, and its y is 2. It's a rectangle. 2 tall, 3 wide. That's 6. This is 10. Guys, this is a curve, even though it's not curvy. It's a function, isn't it? Yeah, Cal.
Is the reason, sorry, one last thing with A.
Yeah, that's okay. Yeah.
Is the reason why when you flip it, it's negative is because dx goes negative backwards?
No. Okay, this is 10, right? Are we good?
Yes.
Okay, cool.
Kind of.
All right. All right, I'm going to shut up and let you guys tackle a few of these, okay?
And then you raise it, and then.
Wait. Yeah, here's another way to look at it. Kyle's got it. Check this out. One more thing. Let's say this is f of x, right? I'm just going to draw it from 0 to 3. And I said it was 4, right? What? It doesn't matter what it looks like, right? I'm going from 0 to 3. Actually, let me do this. Right? And in here is 4 units of area. What's this 2 do to f of x? Moves it up to, nice, Caitlin. So check this out. What I'm doing is I'm inserting a box of area underneath that curve that is 2 units tall. This is now the x-axis rather than redrawing it. I stick this box underneath it. This box is an area of 6. 2 tall, 3 wide.
That makes sense.
Yep.
Okay, that's.
You can do them separately,
Took me.
or you can just shift it, right? All right, I'm done talking. You guys can work on this for a little bit. You can kill off actually a substantial portion of this. It's going to be so page 272. I want you to omit 63. Got a Riemann Sum worksheet. And then page 261, 48, and 50. Now, hang on here. This stuff here, guys, will be due Monday. Since we're quizzing. Sound good? This right here, you probably should work on this tonight, just because I'm going to put it on the quiz tomorrow. Again, it's pretty easy. The key's on my website, okay? And it's actually all worked out. I'm going to give you this worksheet right now. It might be worth your while to like either work on this now, or you can like start some of these just so I can answer some questions before you get out of here. Guys, I know today is Butcher Block Day, but I had a recipe to give you. I changed my mind because I want to do something else. So on Friday, I'm going to move it to Friday. I'll do Fascinating Fact and Butcher Block Day on Friday. I promise I'll make it worth your while. Okay. So anyway, it was just a last minute shift, but it's a really good recipe. It's good. And the timing is really good for Halloween.
Okay, is it
Okay.
Halloween.
It's Halloween-y, yes. Okay. I'm going to give you the, worksheet right now. It's the worst copy ever, but I think you well, thanks for hanging in there, guys. I know
Where's
it's,
the quiz review?
What's that?
If you had quiz review problems written.
that was from my other class.
Oh, no, it's not for us.
Nope. Hey, guys, by the way, one other thing Andrew reminded me of this. If you guys are gone, pretty much from here on out, I have videos for every single section, but I don't post them on my calendar.
Oh.
They're on the video tutorials. So go to the class, hover over it, go to video tutorials. The whole list is there. Yeah, and I don't put them on there because it's just more to move, and I just wanted one-stop shopping for all the videos. So check that out. Okay. Hey guys, I can help you with whatever. You're not disturbing me. I'm going to start grading some quizzes here. Okay, so just let me know.